Welcome to Unit 2, Lesson 5, Sketch Graphs of Derivatives. Sketch means to quickly draw. So if I give you the graph of f of x, we want to be able to quickly draw what the graph of the derivative of f of x, f prime of x, looks like. Remember that derivative just means the slope at any point. So if the graph of f of x is going up like this, then the derivative is going to be positive because going up means the slope is positive. So similarly, if the graph of f of x is going down, then the derivative will be negative. Okay. To go into more detail, let's say that our graph of fx looks like this. So here's our coordinates. Let's say that our graph looks like this. Well, when that happens, then our derivative, we know that this graph of f of x is going up, is increasing, so the derivative has to be positive. In fact, because it's going up at a constant rate, the slope is the same. That means that the derivative must be constant as well. So the derivative will look like this. Constant. Okay. If our graph is instead going down, whoops. If our graph is instead going down like this, let's try this again. Then that means that our derivative is going to be negative somehow. Okay, let's go into more detail now. Let's start with this graph. Well, we know that the graph has positive slope, so the derivative has to be positive. If this is f of x, what does f prime of x derivative looks like? Well, let's think about the slope. It goes across 1, it goes up by 3, so the slope is 3 over 1, which is 3. The slope is 3 here. What about over here? 1, 1, 2, 3. So the slope is 3 everywhere. Because the slope is 3 everywhere, our derivative should look like this. Like that. Why? Because the slope is 3 here, 3 here, 3 here, 3. The slope is 3 everywhere for this graph. So this would be f prime of x. This would be f of x. Okay. Let's see if that's true. I called it a of x. Let's see what a prime of x looks like. Let's Yeah, so a prime of x is equal to 3. That's it. So that's what the graph looks like. In fact, here's our graph. There you go. All right, let's continue with our second graph, b of x. This time the graph looks like this. It's still a straight line. Let's figure out the slope. So here's one point. Here's another point. We go across 3. We go down 2. So that means the slope is negative 2/3. Well, if the slope is negative 2/3, then our derivative is negative 2/3 everywhere, which is roughly here. So if this is b of x, the derivative of b of x, b prime of x, just looks like that. Okay. Next, here's our third graph. this time it's not as simple because it's not a straight line. Well, so the derivative is not going to be the same the whole time now. First of all, let's we see that the graph, let's call this c of x. We see that c of x is going down, right, on this side. So that means that the slope is negative over here. On this side, c of x is going up, so the slope is going to be positive. Here, we have our axis of symmetry. So on the left side, the slope is less than 0. On the right side, the slope is greater than 0. Well, if the slope is less than 0, that just means that our derivative is negative. On this side, it's going up, so our derivative is positive. And at this point, it's not going up, it's not going down. This is what is called the vertex of the parabola. Because it's not going down, not going up, the derivative must be 0. So I'm going to plot the point right here. C prime of x has to be 0 right here. Okay. And we saw that the derivative must be positive on this side, negative on this side. So we know our derivative has to look something like this. It's going up. Our derivative is negative when x is less than negative 1.5, and c prime of x, the derivative is positive when x is greater than negative 1.5. Okay, so that's our prediction. It's just a quick graph. That's what the graph should look like. Let's see if we're right. Go back here. This is c of x. Let's see what c prime of x looks like. C prime of x. Okay, let's go back here. There we go, yeah. So it's negative, positive. I sketched it quickly, so it's not going to be exactly perfect. If we want to be more precise, we can see that roughly here, yeah, but that, it's negative on this side, positive on this side, it's going up. Okay. All right. All right, last graph. Here we go. This is a cubic. The graph goes up and down and then back up again. First of all, let's figure out whether the derivative is positive or negative. In this area, we know that let's call this function d of x. So this is d of x. We want to know what d prime of x looks like. So in this area, the graph is going up. D prime of x is greater than 0. Here, d prime of x is 0. So I'm just going to plot it right here, because d prime of x is 0. In this area, the graph is going down, so d prime of x is less than 0. Here, the slope is 0 again. And then everything to the right, d prime of x is greater than 0 because the graph is going up. So we know that this part, the graph is going up. This part, the graph is coming down, but it's positive, right? Finally, what does the middle look like? Well, it has to look like this. It's going to come down and then come back up. So in fact, when our function is a cubic function, x cubed something, our derivative's graph should the derivative's graph should look like a parabola. And we see right here, it's going to come down until it gets to this point, and then the derivative comes back up. Let's see how close we are to the real thing. Go back to Desmos, d prime of x. Come back over here. Yeah, we're pretty close. we see that the graph is the derivative is positive on this side, and then negative, and then positive again. So that's how we can sketch the graphs of functions, well, graphs of the derivatives of functions. So to summarize, if our graph looks like this, well, the slope doesn't change, so our derivative looks like this. If our graph is a quadratic, like a parabola, well, the slope is going down and then coming up. Then we see that the slope for this one initially is negative and then becomes positive. And if our graph of fx is a cubic like this, well, this cubic is going up and then down and up again. That means that the derivative is positive and then negative and then positive again. All right. That's it for this video.